So yes, the recording is started. Welcome everyone to this session. Thanks again, first of all, like joining on a very short notice. So this is just a regular session which I am doing. That I will discuss why this topic is important, right? Because a lot of us are working in the generative AI field, or even if not in Gen AI, any kind of developer role. If you are doing maybe data engineering, data science, uh, this topic is very extremely important. Uh, so I think, yeah. Okay, yeah. So we will start the session now. I think recording has started. Just checking. Okay. So let's first of all understand what is can someone tell me what is the meaning of scaling of an application? When I say that we say we want to scale an application, what is the meaning of that? And just guys, please try to be interactive, right? We will not extend the session beyond the designated time, but just try to be interactive so that you can understand. Don't depend on recording. Okay. So what do you think? What is the meaning of scaling an application?
Increasing number of users.
Many users can join at a particular website. So for example, let us say this is my website, right? Data science website. Now presently it is like a lot of less users are there, but because we are building it. But what happens over the time, people will come in and the load will increase. So what happens that any application that you build, how does it go? What is the life cycle of an application? That first of all, that whenever you build an application, first of all, you build inside a certain, let's suppose you are working in a company, right? You will build that application inside among your team only. Let's say you're working in a in a team A, right? And your team contains of, for example, 10 people. So first of all, what will you do? You will just build your application inside team, and let us say you have built a Gen AI application or whatever, and all your friends, like these 10 people, only these 10 people are accessing the website. The moment you take this website, let's say, so this is your team right now. What happens now after this? You take this application to multiple teams. Okay, team A, team B, and team C. So suppose there were 10 people here, now it become 500 people. Okay, so will your app, so ideally your application should behave similarly. What do I mean by similarly? That whenever you go to a website, right, you want it to be quick. Let's say you are logging in, you are watching a video or whatever you're doing, it should, the response time should be very quick, right? It should not lag away. So from 10 to 500, it is still easy. Now suppose after this you scale it at entire your company level. Suppose your company has 50,000 people, right? So you 10 to 500 to 5,000, and after from the company, suppose you shifted to your state, for example, which contain one, for example, I will say 500K people, right? And from there, suppose 5 million people, and from there, suppose 1 billion people, right? So tell me what complexity is getting added. What do you think? What could be the hindrance that even so people here initially who were able to access the website at what speed, the person here also should also be able to access the website at the same. And it is not only website, guys. As I mentioned, it can be any HTML website, web application, your mobile application, could be anything. The concept applies to everywhere. So what do you think is the hindrance? Why does the performance of an application stop uh, over the time? What do you think? Many users send requests, right? So that is one of the reason. Increasing the, yes. So what is happening right now, initially what happens, suppose let us say I create a website in my computer. Now my computer, let us say it has a, for example, it has a, so my laptop presently suppose has a one TB hard disk and it has a 48 GB RAM. Okay, which is very good for me, but it is good for me only. If million people keep on sending requests to this laptop, right, this laptop will break. It will not be able to handle such a big load, correct? And whenever we go to any website, like especially website like Instagram, Facebook, or whatever we use, we expect very quick response time. Even like we have become so impatient that we cannot even wait but 2 seconds. Like even if a website lags for a second, we just start like complaining that okay, something is wrong, something wrong. So this is the reason I'm taking up this topic, because what happens, a lot of you who are working, let's say who are exploring GenAI application or whatever, okay, yeah, good that you build an application, but what happens when you come in a company, you see a very big gap, that the projects that you do on your local systems, which you share with your friends, which you do in any course, right, those projects are what those projects are very small projects, small data, right, they run very smoothly. There you can design any architecture, it will work perfectly. But when you move to a company, you will see that not all designs are accepted. Even if you think a particular solution, that you think that okay, this solution is very good to me, it might not be accepted at the company level. Okay, and this is the reason I brought this topic, because over the time I have also realized that what I used to do and in my local systems, thinking that okay, these toy applications are very good, but when I went to the company, I realized that okay, no, this is not something I really need to change my mindset before. So when you're designing an application, you need to think from an architecture point of view, not only the functionality, you also have to see that whether that application will be able to sustain the customers or not. Okay, this is the reason this session is there, that how to scale your application so that you can address one person as well, 100 plus people as well, 1000 people as well, and 1 lakh people as well, and 1 million people as well, right? So this is the whole objective. Now everything cannot be covered in one session, but I will try to cover all the major concepts which are there. After the session you can go and explore and read on yourself as well. Okay, any doubt anyone before I start the session? This was just the introduction. If you have any question, let me know, please. Okay, at any point of time, if you don't understand, please let me know. Okay, uh, this is a very theoretical session where we'll discuss things conceptually, how they are growing. So please try to be interactive. Okay. Okay, so now let's move towards, so like any application that you build today, your objective is that today if I have one person on my website, tomorrow even if multiple people are coming, I should be able to address them. That's what I thought, right? For example, let's say we all see Google, right? On Google, 99,000 searches, uh wait a second. Yeah, on Google, 99,000 searches appear per second, which means approximately 8.5 billion searches per day, right? If you divide it by the number of servers and all that, it requires a very robust system. Okay, it's not that easy that you build anything on your local computer and it will work. Same with Instagram. There are like 4,000 posts like per second, 1 billion per stories are shared daily. With WhatsApp, 69 million messages per minute, and 1 billion plus stories shared daily, right? So I mean, these are the big, why I took this example, because this is something we use daily, and we really need to understand, at least to appreciate that how like what smart architecture, what smart engineering is going in the backend. Okay, so what we see when we see a website, what happens that whatever we see, it's just a tip of the iceberg. For example, we go to a website, we'll watch a video, and maybe you will click on something, you'll comment something, or you will click something and you'll think okay, and then you'll get a clean UI, right? This is what a layman, not a layman, any general person sees, right? But you as an engineers, right, if you plan to design an application, you need to understand there is lot going in the backend. What all things are going in the backend? something is called load balancer. I will tell you everything. Microservices, cloud auto scaling groups. There is CDN. There is distributed databases. There is service discovery, monitoring systems, disaster recovery systems, and security API gateways. Like, plus there are more topics. These are just the basic ones. So let's try to understand. So what I will do, we will try to build an application from one user right now, and I will introduce concepts one by one. There are total 10 to 11 terms which you need to know, and we will see how the architecture of my application increases from one user to a multiple users. Okay, so let us say I have just a single server setup. So before I ask, tell me, what is a server? What do you think? What is a server? We all say this word almost every time, right? What do you think is a server if I ask you to define me a server? I will let you know the YouTube channel, don't worry. Tell me, what is a server? High capacity machine, okay. Remote computer, okay. Serves any request. It's fine, but not the perfect definition. A machine that handles request, okay. In short, like, now there can be very complex definition of server as well, but if I have to tell you in a very layman term, server is just another computer. If you run an application on your computer, that your computer is also a server. So suppose you created an application, you created a Docker file, Docker image, and you hosted an application and you sent a link to someone else. If that application is running on your system and someone else is using it, then your system is also a server. Okay, so we say so server is a computer or a system that provides resources like data, services, or program, whatever, right? And called clients over a network. So for example, if we we have a client and we have a server. So client is someone who requests something. So for example, you go to a website and you type that, suppose you type on YouTube that I want to see machine learning videos. For example, you type this text. So you will become a client, right, which will request something. Okay, and there YouTube or whatever website you have gone, it will process your text and it will respond you something, right? So this is a server. So technically your device will say that, okay, I want this content, and website on which you go, it will provide you something. So your website or device is a client, and whatever service that is providing you, whether you call it YouTube or anything. Now YouTube is just a website. In the back end, it has servers, right, which will respond to it. So server are just, in back end, there are multiple computers, you can say, which basically work and they respond to your queries. Now there are, or we say server is just a specialized computer, which is often stronger than a personal laptop. But the main applications of a server are that it waits for a request, that whenever you send something to it, it will accept your request, process it, and return to you. Okay, so it will wait for a request, process your request, and respond it with the result. And there are multiple server. Again, we don't need to go much in deep. Like there is a web server which delivers websites, database server, we see MySQL, MongoDB, file server, application server, mail server. There are a lot of things. So basically, technically, a server is just a computer for now, think that, which will process your application, on which your application is hosted. Okay, so this is the architecture of a very single application. So what is happening, that this is the user here. If you see, this is a user. A user can access a server through a web browser, or he can access through a mobile app. Okay, so suppose you type a website that www.this.com. What happens in the backend? What do you think? When I go to a website, when I go to Google Chrome, I type down www.google.com. What happens?
DNS resolution will happen.
Yes. So there is a thing called DNS. Okay. So DNS, what is sorry for the DNS stands for domain name system, right? And it is just, so think like your phone. Uh, how do you say remember contacts of people? You don't actually remember, you save their contacts by their name. For example, you have multiple friends, multiple people, right? You would have 1,000 contacts in your phone. So whenever you have to call someone, do you actually dial their number, or do you type their name, or do you just dial, check their name and dial that, right? You simply go to the, you open your phone directory, go to that person's name, and you simply dial them. And what happens in the backend, that name that you have, suppose I have a person with name ABC, okay, or let's say I have a person with name John. His number is suppose 9915332445, something like this. Whenever I tap John, John will link to this number and this number will be dialed, correct? So this is what happens in an application, that whenever you type down your website name or any website name, it does not automatically goes to the server. What happens is that your, this is DNS. First of all, your request goes to a DNS. What was DNS? DNS was domain name system. Every website that you see is linked with an so basically it will go to the DNS of that website, and it will return the IP address of that particular website. And this is DNS. If I show you online, right, domain name system, it is this. So you can think like DNS is a repository where for every website it has stored its IP address. You don't need to study it in detail right now, just understand this. It's like a phone book where every website and where that website is hosted. Suppose a website is hosted on your laptop. Google.com must be hosted on a server name, right? It must have some IP address. So whenever you type down any website name, what will happen? First of all, that request goes to the DNS server, right? And this is a third-party application only, and it will return it the, so it will return it the IP address. Now that it has the IP address, your browser or wherever you are, it will because of this, that IP address. Remember, every device has a unique IP address. So now your web browser will know that which system to connect to because of this IP address, and then it will send a request to this web server, and when it receives the request, it will return you the HTML page. Okay, so what are the steps? I will type down a website. That request will go to DNS server. DNS server will convert my website name to an IP address. Then the request to that that IP address will be sent, and that IP address will return me that particular web page. That's how a single server application works. Any doubt, anyone, on this part? And trust me, this is just the first part. We are going to scale this application. This is just one server, means remotely one server is sitting, someone is accessing that particular server. So this is how it is working. Okay.
So this DNS is a sort of an application.
It's you can think like that. It is kind of storage information, right? It's not an application. It's a storage information where it refers. It's kind of dictionary, you can say. Server, I just told that server is just like a computer. You can think server like a computer which is stored at any place. So I told you server is what? Server is a computer, a system that provides resources. So my computer can be a server, your computer can be a server, some advanced computer can also be server. So server is just a computer where any application, anything is hosted. Okay. Any doubt, anyone, before I move ahead? So this is the architecture of your basic application, which is hosted on a single server. Shall we move ahead? Any doubt, anyone? Okay. So as I mentioned, users access website through domain names such as this, and domain names is a paid service provided by third party, which I told, and IP address is received, and once IP address is received, you send request to that IP address, and that IP address returns you the website. So this is the first part. Now, if you see, whenever your system will connect to a server, it talks in a certain language. We generally call it API, right? And those communication happen in form of a JSON data. And this is how a JSON data looks like. So far, you would have seen data like tabular data, right? But in real time, tabular data takes time to process. And this is the reason the servers which communicate with each other, right? They communicate in form of JSON. So how it is that this is one row, that ID is equal to 12, first name John, last name Smith, address, right? So it happens in key value pair, which is a dictionary. Okay. And this whole is called a JSON format. Okay, this is how servers communicate with each other whenever API is sent from one system to other. This is how they respond. Okay, so this is the technically you can say this is the language to speak, how they communicate with it. Now let's come to the second part, database. So far what we have seen that this is our application. We are sending information to this and we are getting information. So far, is there any storage in the system? In our application, is any information getting stored anywhere?
No.
No. Suppose your information was getting stored on this computer. What is server? This is just a computer, right? Suppose whatever you're processing is getting stored in a SQL table in this particular computer. Is it good an approach or a wrong approach?
Good approach.
But what if your server crashes down? Then you will lose this information.
Something cache memory kind of.
No, so you don't use cache memory here because you don't have you first of all store it in a data. So what you do that this is an addition to our architecture, that what we do that in addition to what we were doing, every time user queries, user sends a request to this, that information is put in a database in parallel. Okay, so you first of all write or update the database, and then you read from that, and then you respond to user, so that you can have a track record of whatever is going on with your system. Okay, so far we just saw that it was a single system. Now we have added a database. So even if my system server crashes, I can bring another server, but I will still have all the history of my databases so far, of whatever interactions I have done so far. Is it clear, guys?
So is this happening through like GET request and then POST request, something with APIs?
Yes. Whenever you ask, so how things work, that whenever you go to a website, let us say I go to Amazon.com, whatever activity I do on this website gets stored in a database. So
Okay.
that remember, the companies, the websites remember what you have done, your progress and everything. So
Yeah, it
all
stores password and
information,
username and all.
yeah, everything is stored in a database. So whatever you do on this server will be stored here, and whenever you access this next time, it can retrieve your information from this database.
So in previous slide, data was stored in a server only.
Where? Yeah, in the previous, what was happening, you were storing on server. Okay, the problem with server is that if your server crashes, suppose let's say I'm hosting a website on my system and I'm storing all customers data on my computer. Suppose my computer crashes, so you will lose all the data. So a better approach is to install an external hard disk, right? Install an external hard disk or somewhere else where whatever data is coming is stored there, so that even if my system crashes, right, the data is still there. I can plug in a new server and I can start functioning smoothly. Is it clear, guys? Any doubt? We have just started. This is just a very basic application yet. Please watch this session till the end, right? Because we are going to introduce a lot of good concepts. So far, what is our application? We are getting a request from user. We are storing that information in. First of all, through DNS, we are getting the IP address. Then we are accessing the web server. The server is storing information in the database and returning me the information. All good so far? Now let's talk about vertical scaling and horizontal scaling. Suppose what happens right now, there is one user only. So what will happen if there are 10,000 users? And suppose my computer, let's say it is 10 GB RAM, okay? And my computer, let's say it has 10 GB memory. Assume one person takes 1 GB. So how much memory will be required?
10,000.
10,000. Okay, let's scale 100 people, right? So 100 GB will be required, right? My computer can only process 10 GB. So what can I do here?
We can keep 10 that servers.
Scaling.
So what type of scaling? There are two ways in which you can scale. Either you can increase the power of this server, right? You can install additional memories. You can say, okay, right now it is 10 GB. I can install more memory to this computer. So instead of 10 GB, I can make this computer 500 GB. That is one method. Or I can say, okay, this is 10 GB. I will do 10. I'll add 10 more servers of 10 GB. Right? So these two types of scaling are present. So let me tell you, so these are called vertical scaling and horizontal scaling. What is a vertical scaling? Vertical scaling is when you take your original server and you increase its memory. See, this was my original server, you increase it. It was, let's say, initially 10 GB, then you increase to 50 GB, and then you increase to 100 GB. So this is called increasing CPU RAM of your system. Or there is another method called where you keep the same server of 10 GB, but you introduce multiple servers, 10 GB, 10 GB, 10 GB. So you even here you have 80 GB, here also you will have, like, let's say 80 GB, whatever memory. Okay. So one is called vertical scaling. Vertical scaling means increasing the power of the same computer. Horizontal scaling means introducing multiple servers which can handle requests. Now tell me, which method you think is better, or which is what is the positive or negative of each? What do you think?
I think horizontal scaling is better, because in vertical scaling we again and again have to upgrade our system. That could require some challenges in the name of, like, how much our original server had the capabilities or capacity to increase.
Okay, suppose I don't have that problem. Let's say I can scale it up to any number of level. Then
I think vertical scaling will be better,
why not horizontal?
because I think cost would be more in horizontal scaling.
Okay, any other
So
answer?
I think horizontal scaling would be the better option, because if the system crashes, the vertical scaling will.
Exactly. See, I'm assuming whoever is building this company has a lot of money. Okay, so Point is, our main objective is that our system should be reliable. Okay. Now think like this, even if you increase, yes, I agree that if you increase same computer you can increase the memory. But think like this, have you heard this line, don't put all your apples in the same basket, something like that. The problem is that even if your computer is super powerful, if it crashes, everything is gone. Yes or no?
Yes.
And in horizontal serving, what will happen? Even if one crashes, your server can route to this, can route to this, can route to this, can route to any number of to any place. This is the reason. So vertical scaling, first of all, it has a hard limit. You cannot scale, as you mentioned, beyond a boundary. That, like, even if you see your local computers which you use, you can expand up to a certain level only. You cannot expand indefinitely. That is the first problem. Second problem, that if there is a failover, here you're totally gone. Here you will have option to recover. Okay, so that is why horizontal scaling is more desirable for large scale applications due to the limitations of this vertical scaling, and that is why people prefer this particular thing, horizontal scale. Is it clear, guys? Any doubt? Now think like this, what was happening, that this was my original, if I go here, I was getting the request from here, right? And suppose I have 3 servers. Now it becomes very important that if I have 3 servers, all my requests should be uniformly distributed. Why is it so?
It's called load balancing.
Yeah, I don't want it. The main problem is that if I have 10 computers, right, I want that each, whatever load is coming from the back end, right, it should be distributed uniformly to all the systems, so that my system, any single server does not scale up, does not heat up, or does not reach to its capacity. Okay, so this thing is achieved by a load balancer. So what does a load balancer do here? That if you see, whatever request comes, it will evenly distribute between the servers. Okay, so it's not that 90% load is going here, 10% load is going here. No. And this is why when you will study Kubernetes, or when you will go towards the deployment part of your applications, you will see that you won't be able to see on what computer your application is running. Your application might be running 50% from this, 50% from this, something like that might be happening, right? You will just see that, okay, my application is distributed across 3 computers, and which computer is handling what, even you don't know. Okay, so this is the first part of the load balancer, that it takes the load whatever is coming. Let's say 50 users are coming, so it will split evenly. It will say, okay, 16, 6, so 25, 25, it will split evenly there. Another thing, let me tell you, again, that's not in the scope of this lecture, but lot of hacking which people do is that, suppose, let's say a hacker is there, a hacker is accessing through a mobile, and it is accessing your server. What can he do? He can access the IP address of your system, and he can crash your system, or basically he can plug virus to your system, or anything you can do. What load balancer does is that it does a very special thing, that load balancer has its own public IP address. Okay, and these servers have a private IP address. So what happens, that whenever a user is accessing a website, so let's say you go to a particular website, facebook.com, you will not be able to directly see the IP address of their servers. What you will see, the IP address that you see is the IP address of the load balancer. Okay, so even if you do something here, your servers will be saved, and all these IP address remain private to the organization level only. Okay, so this is a very smart way that it will take the request from here and it will automatically distribute among the IP address that it has. Okay, is it clear, guys? So there are two things that load balancer does. First of all, it distributes the load equally. Second, it protects your servers from harmful requests. Any doubt?
So, load balancer is like what exactly? Like, it is doing two things that I understand, but what exactly is this thing?
It can be a program, it can be an additional server, it could be anything.
Okay, okay.
Mostly it will be a server only, but yeah, mostly it's a server only, but this only does, it's only used to route the requests that are coming. It does not itself run any application. So it's like a messenger, you can say. These all terms are very, you will see, you might not be seeing nowadays, but whenever you'll come in a company, you'll work as a developer, you will see these terms are very frequently used, and people, like, no one will give you formal training for this. People will expect you to know. That's why I'm covering this, that you just listen these words. Even if you don't understand, go back and study them. These are important. Okay, so this is the, so far this is the architecture of our application, that we have a user will send a request, it will go to DNS, DNS will give the IP address, IP address will go to the load balancer will basically distribute the loads equally at both places, and there will be a database. Okay, and is it clear, guys? Any doubt in anyone? And there will also be a database here, which I forgot to add. Shall I move ahead? Okay, now let's go. I'll share this PPT. You can read all this topic from there, but now let's study about database replication. So far, what is happening? All my requests, everything that is happening in this server, just like you saw these servers, right? Why did we create multiple servers? Tell me.
To increase the capacity.
To increase the capacity, first of all. Second, if there is a failover, other servers should be able to handle the requests, right? Same thing for database. So far, I have information stored only in one database. I don't want, as I mentioned, all my fruits in the same basket. I want that I will introduce the concept of database replication. So what will happen, that this is the web server that you are having, and so there will be two types of, this is the concept of master and slave. Okay, so you will have a master database, which is this. Now all the web servers, whatever activity happens at your servers, they will write down those information to your master database. Okay, and then you will have these slave databases, which will not be nothing but just a copy of this write database. Okay, whatever this database, it will just create duplicate copies of those particular database. And these servers, so this particular will have access to write, and these are only read-only databases. So a web server will write data to this, and then it will read data from this. Okay, is it clear so far that what is happening? Same information.
Also,
So
one question. The whole data is getting copied to each and every slave server, right?
yes.
Okay.
Not server, database.
Yeah, database. Like there's no partition of it. Itna hai, sab
Right, partition I will introduce in the end. Right now, everything is same. So suppose there are 1,000 rows here, same 1,000 rows will be in this, same will be in this, same will be in this.
Okay.
What is the reason for this?
So that if data will be lost in one, we can access other.
You can access it from somewhere else, right? Okay. And remember, this is a read only, this is a write on, you can write it. So formally, whenever a data comes, it writes to this database, and then these database copy from this particular thing. So what happens? The master handles all the write operations, whatever is there, write, read, write, insert, whatever is there, master will handle. And reads are spread across the slave databases. Okay, enabling parallel query. Now, what happens that if one slave, so if your one slave goes offline, suppose it crashed, your web servers can read from the other one, other slave, right? So if your one slave goes offline, reads are rerouted to a healthy replicas or temporary to the master. Suppose there is only one slave. If that slave goes down, it will route the request to master DB. So it will have always. And if your master goes offline, then a slave can be promoted to the master, maintaining the uninterrupted operation. Okay, so that is something, it happens automatically in the backend, like either through Kubernetes or AWS Azure cloud. But you should know what is happening. Eventually you won't be coding all this all thing is properly integrated in the backend, but you should know what is happening where and how to set those things. Okay, and this is how. So for servers you create horizontal scaling, and for databases you create replicas, so that your information is not lost. Is it clear, guys? Any doubt?
Perfect. So these are all non-relational databases, right?
It could be anything. It could be non-relational, relational. It could be anything.
Okay.
For now, I have not distinguished that what kind of database it is. So it could be SQL, NoSQL, anything for now. Generally, web servers store information in form of NoSQL only, but I'm just saying that, I mean, there can be like exceptions as well, but okay. All good so far? So our design so far is like this. If you see that this is my user, it sends request here, gets IP address. Now load balancer will route the request to the servers. Now this server will write down to a master DB, right? And it will create a replica to a slave database. Okay, so this is my architecture so far. Please see it once again. Let me know if you have any doubt before I move ahead. We are done with 50%.
I'm not getting writing down.
Sorry?
What does that mean, writing down?
Writing down means?
There are two servers, no? Like there are, after load balancing, load is getting distributed uniformly. So that servers are going to master's DB for writing and then reading. So what is this there actually happening?
Which I told here, that web servers, whenever a data will come, they will write it down to a master database. And when they have to read the same information, they will not access the master DB, they will read from the slave database. If I come to this, what is happening? This server one is first of all writing to the master database. And when it has to read that information, it will go to the slave database. Same with the server 2. Whenever a new information comes, it writes down to the master DB, and when it has to access that information, it accesses through the slave database. And because these two contain the same information, so it will always have the same result. So guys, please have a look at this architecture so far that we have created. Any doubt? This is the architecture of any big company, any big application, YouTube, Google, whatever you see, everything has this same architecture design, similar. I mean, few things might get vary, but almost 60-70% things are same only. Okay, I'm moving ahead now. Now I'm introducing the concept of cache. Okay, so cache, we all know that over the time, suppose you're sending the same request, right? Suppose you let's say you are searching for a keyword. Let's say you search for India, right, on Google, and it will give you some result. Now what you will do next, so suppose you type India and you get information from server, it takes 5000 milliseconds. Now every time, now this information is static, right? You don't want to spend 5000 millisecond every time. So what you do, that you take this information that okay, India, and its value was something, whatever it was, you will create an ID to this and you will store it in a cache memory. Now that cache memory is mostly Redis, or it can be, there are multiple cache databases which we can see, right? So that whenever a new request comes which contains the same word India, it will not execute the database. Now it will directly hit the cache memory, and cache memory might take only 30 milliseconds. So your performance increases. Okay, this is the core concept of cache, that whenever user tries to attempt those queries which he has accessed earlier, and that information which is static. Now for example, let's say a user is asking live temperature, okay, and suppose a user is asking tell me the history of India. Two queries are there. Tell me which query should go into cache and which not.
India will go on cache memory because it has earlier asked.
No, suppose both questions have been earlier asked. Which information will you put in cache and which will you not put in cache?
Yeah, history of India, as it is a static page and it will not change.
Exactly. History of India is a static page, right? This content is not changing. So you will put it in cache memory. The live temperature, it keeps on changing every day, right? So there is no point of caching such an information which is changing. So you cache only those information which keep on which are static over the time and which are queried many times. Suppose, right, so which are queried many times, that information only you cache. So there are two conditions which you have to keep in mind. Whatever the query is, it should have high frequency. Second, it should be static, it should not be dynamic. Okay, so a cache memory is a temporary storage that stores the result of expensive responses, okay, or frequently accessed data. As I mentioned, frequently accessed data in memory, so that subsequent requests are served more quickly. That is the objective of cache. And every time a new web page loads, basically what will happen, one or more database calls are executed, and they are very expensive. So that is why you try to avoid them and you simply store in a cache memory. So what happens, that if the data exists in cache, you will read from cache. Otherwise, you will run the database and you will store it in cache, and next time onwards, you will answer from cache only. Okay, so after receiving a request, a web server first checks if the cache has the available data. If it has, it sends the data back to the client. Otherwise, it queries the database, stores the response in a cache, and then sends back to the client. This is called a read-through cache, but this is how cache works. You can read more about cache, but this is the overall objective of a cache memory. Any doubt, anyone? Okay, so this is how a cache memory looks like. So for example, first of all, you will set in the cache. So this is a screenshot from a Redis database that you will first of all set. So what you will do, whatever the query had, you will give it a key, and after that you will fetch that key from here, so that this information is stored. As I mentioned, use cache for frequently read, rarely updated data, right? Information which is very frequently used and it is static. Okay. Avoid caching critical or persistent data, because cache memory which we use, it's a it's not a long persistent memory. You keep on deleting your cache memory after every few days, few minutes, as per your condition, right? So you don't store your major information there. You only store things which you think a lot of requests are coming and you can have it there. Okay. You also set an expiration policy, which I mentioned, that you don't want to store your cache for long. Okay. And okay, yeah, I mean, all this is fine. This is not the main is to understand how does a cache memory work. Okay. All good. Anyone,
So
any
in
doubt?
terms of live temperature or any, yeah, in terms of live temperature or something that is live. So that query goes to the database every time and it doesn't get stored into cache memory. So would it be
You
happen like
should not store.
continuously?
Yeah, you should not store in cache because live temperature keeps on changing, right? So you can, I mean, there's no point of, there's no logic of storing it in cache memory. In cache memory, you only store that information which is, for example, someone's name is there, someone's password or user ID is there. Those things you can store in cache memory. But temperature or someone's bank balance, right? Those kind of information does not make sense to store in a cache memory. Any doubt, anyone? Now we're moving to the, like, we're done with 60-70% of the session. Next topic, which is content delivery network. That is also called CDN. Okay. What happens that a lot of time you load static information online. Okay. So like images, those images, for example, they do not, let's say I load a website, right? Website has some image. Now, those websites, they do not directly come from server. They come from content delivery network. So what is a content delivery network? Let me tell you that it depends upon your location. So for example, let us say I'm located in a particular city. Whatever the nearest CDN center is, content delivery network is there, I will get response from there. So suppose user A requests an image that, okay, I need a particular image. First of all, that information will not go to the server. It will go to a CDN. It will check whether that information is present in CDN or not. So CDN is also like a cache memory, but think like this, the cache memory that you see here, we read here, it is stored in your application. But this type of cache memory, CDN, it is not stored in an application. It is a global, you can think of it as a global cache memory, right? Which everyone can access. So a cache memory of your server, of your application, will remain on your server, on your application. But this is something which is present global. For example, an image, if a lot of people are requesting, so it will present in this CDN. So that same, it works exactly like cache memory, that user will request an image. If it is present in the CDN, he will return. Otherwise, it will get from the server, it will store in this CDN, and it will give to the user. Okay. And you get CDN which is near to your location. So like there are a lot of CDN centers, you can Google it, right? And the information that you get it from the local center. So a CDN is a group of globally distributed servers used to deliver static content like images, codes, and videos. For example, the YouTube videos that you see, right? They are stored in a globally distributed in a CDN. They do not come from YouTube servers live. Okay. And they are like cache static files close to end users, reducing the time it takes to load the websites. So now you must be thinking, what is the difference between cache and CDN? Can anyone answer me this? The difference, I spoke about cache
Cache is
memory.
application like local.
Yes, cache is respective to me,
And then
right? Let's say
CDN
I
is
am using an
global.
application. CDN is global. It is for every user. Suppose I just checked a video online, YouTube, right? So suppose let's say I'm sitting here. Okay, I just went to YouTube and I asked for a video. So what it will do now, initially CDN will not have, it will go fetch from the server and store in CDN and return to me. Now next time another person who is living close to me, he checks, he will be able to access that from CDN. So this is how CDN memory works. But this only stores static content like images, videos that you see, only those parts, not the dynamic things. Okay. So this is it. I'll send. So this is the architecture so far of our application. That this is originally, whenever a user sends a request, first of all you check in the CDN. Okay. If it is not present in the CDN, you will send the request to server. Server will have master, slave, and it will also have cache memory. Okay. Please see the architecture. Let me know if you have any doubts so far. We're moving to the last part of the session.
I'm not very sure what cache is. Can you please tell what cache is?
Cache is just like, for example, let's say, let's see a very simple example. We are using chatbot, right? We created an GenAI chatbot, and I'm asking a question that what is the summary of this document, for example? Okay, summary of this document. Suppose this is the request. Now, when you will send this to, suppose you send this to OpenAI, right? You make an OpenAI call, it will cost you some money, yes or no? And suppose OpenAI takes 10 seconds to process your requests. So in how much time will you get the answer?
After the processing time.
10 seconds, right?
Yeah.
The processing time is 10 seconds. And suppose every request charges you $1. So suppose you want to see this summary 10 times. So you will be spending, suppose you want this answer, you check this question 100 times a day. So over a day, you will be spending $100, right? But what you can do, instead of querying ChatGPT always, OpenAI always, you can store this question and its answer in a separate database, which is called a cache memory. Okay, so that whenever you ask this question, you will check, is this information already present in cache memory? If it is present in cache memory, you don't need to hit OpenAI, you will directly get it from here. And because it's a database, it will not cost you any money. And it will be very fast as well. If it is taking 10 seconds here, it will take like 0.05 seconds here. Is it clear now? Yes or no? So this is the architecture we have covered so far. Let me know if you guys have any doubt. Please try to visualize in your mind that, try to create the flow from here to till this particular point in mind. See how things are connected.
So is this the architecture of any mobile application or any website?
Not only mobile, it is mobile, website, anything. Mobile, web application, anything. Facebook, Google, whatever you think, everything has similar architecture. Okay.
So what is the difference between these DNS and then CDN? CDN is for images and videos, and then DNS is for text.
DNS, as I told at the start, DNS is just a dictionary which contains your website name and its IP address. Whenever you type down www.google.com, it will go to the DNS. DNS will return you its IP address. That IP address you will pass to the load balancer or CDN, wherever you want to. This is the objective of DNS. So DNS stores the IP address, CDN stores the static content. Load balancer takes a request, route to the server, and then from those servers create master database or slave database, and the frequently asked question you put in cache memory.
So this is how the way the scalable applications can be built with the using this kind of architecture.
Yes, yes. This is how every application is scaled. Any doubt, anyone, before I move ahead?
Yeah,
Couple
hello.
of more concepts. Yeah, please.
Yeah, actually, I have one doubt related to cache memory.
Yeah,
So,
please.
what doubt I have, like, let's suppose any user asks, like, provide me the summary of this document. So,
Yes,
let's suppose whatever like information we got from the vector DB or from somewhere. So, we
yeah,
store that information into the vector DB,
yes.
into the cache memory. Correct. I
We
think
don't
up to
store
here I am
vector data,
correct.
we store the output in the cache memory, question and answer, nothing else.
Yes. Yeah. So the benefit of the cache memory we want to use as it like in future if any new query is coming, they want to get the summary of that document. So rather than going to the doing the semantics or so whatever, we
Yes,
want to provide the answer from the cache memory.
from the
Correct?
cache memory, yes. Because see,
Yeah.
semantic search will cost your embedding model some money, right? Then
Yeah.
doing the
Yeah.
vector search takes some time as well. But when
Yeah.
you do, if
So
you're asking the same question, you can put in cache memory. You just don't need to query a database. You can simply pull from that cache memory.
yeah, so the doubt I have here is like let's suppose any user came and he asks us to provide me summary of this document, and
Yes,
another user is coming and he's saying that the provide the summary. So here the two sent query is different.
yes.
Like the
That is something you need to build. That how you set up your cache memory, right? So what you do that the question you put
Mhm.
some like fuzzy matching there as well, that okay, it not the and it might not match the exact wording, but even if the semantically it is similar, you can still route it to the cache memory. So those logics can be built in cache while you are setting up your cache memory.
Okay, so while we are doing the searching from the key and value from the cache means we will be searching the key only
You'll be
from the
searching the
cache.
key, right? And the search can be simple word based search, or it can be semantic search, you can introduce multiple logic there to retrieve faster.
Okay, got it. Okay. Yeah, thanks for clearing this out.
Yeah,
Thank you.
no problem, no problem. Anyone, any other doubt before I move ahead? Okay, let's move to the last couple of topics. Now we're talking about stateless web tier. So there are two types of applications, two types of structure. One is called stateful and one is called stateless. Okay, so let's try to see what is a stateful architecture. Now suppose these are three servers. Okay, user A comes here. He has his password, everything, right? And let's say initially is connected to server one. So all his session data, remember what is server? Server is just a computer only, right? So all his session data, whatever he did, and profile image, password, everything is stored on server one. This is called a stateful architecture where the server stores your information. Is it clear? Tell me, is it a good thing or it is a bad thing? What do you think?
A bad thing,
Why?
because again we discussed it like the crashing issue.
One thing is of course the crashing issue. Yes. Another issue is that if we go back, this is our load balancer, right? Load balancer, let's say right now I'm talking to us, I'm doing something. I do not know to which server it has connected me. Remember, I only have access to the IP address of the load balancer. In the backend, load balancer could have connected me to any computer. So think like this. Today, right now, I log into a website, I put my password, I did something there, it stored my activity. In the evening, I logged into website again, it might not have my information. Why?
I am connected to the server.
Because it might have connected me to a different server now. Do you get this part? In the morning, I was connected to server 1. Okay. So all my credential or my activities were stored in this. In the evening, it connected me to server 3. So whatever work I did here, this server 3 will not know about this. Yes or no?
Yes.
Right. So this stateless, this stateful architecture is not recommended, that any of your private information, your browsing data, your password, or whatever you have done, it should not be stored on any server. It should be stored in a separate place. Yes or no? It should be stored at a place which any server can access and retrieve from, right? So instead of storing information here, it should have stored all this information in some database or whatever I say, so that whenever I connect to the server can retrieve my information from that particular database and I can have a smooth flow. Yes or not? Tell me.
Yes.
This type of architecture is called stateless architecture. So it means that your information is shared over a storage. It could be, so mostly it's a JSON storage, a NoSQL database. So user A, user B, user C will connect to the servers. Servers will not store any information inside them. Rather, they will put the information in a shared storage. Okay. Now this is mostly a NoSQL. It could be a MongoDB, Couchbase, or whatever type of database it is there. Cassandra, GraphDB, it could be anything. But this information will be stored in this shared storage. And whenever a server has to access, it will fetch your information from shared storage and then be able to answer. Okay. So let's read about this. To scale web servers horizontally, session state data like user login info must be moved out of individual servers, because we do not want to depend on, see, the core principle is that I do not want to depend on a single server. If you try to notice, whatever we have been doing so far is we have been trying our dependency on one single server. Okay. Stateful servers store the session data locally, requiring all of a user's request to hit the same server. And they complicated scaling because, as I mentioned, right, you do not know which server you will be able to connect to. A stateless server do not store user session data locally. Instead, all the state is kept in a shared data. Okay. This is the difference between a stateless and the state architecture. Now, this is my updated architecture that I have, apart from a cache, I have also added a basically this is a shared state. Okay, which will contain my information. So are you seeing how a simple application which looks like so many complex things are there? Now we are talking on an architecture level only. If you go deep inside into each concept, each topic, it's again a whole like new world, right? But just try to visualize how things work. Like, things are not that easy that we think. Just building an application on a computer where a chatbot answers something is just one part of it, just the beginning. To take that application to scaling level is something requires the real engineering, right? So again, you guys will learn as you like work in the industry, but even if you don't work, you should know how things are working in the backend. Yes, please.
Yes, so my question is, when we are practicing any concept, we kind of do a hands-on on our system. But
Yes.
this concept, how can we do hands-on, because we don't have server and like
You
locally we can't do anything.
You cannot do hands-on unless you are working in a company. Or what you can do, you can use cloud, right? AWS cloud, or maybe any cloud right? Try to host application on that. Try to create your own Kubernetes cluster, okay, and see how you can scale up things. So it does not cost money. So best thing, suppose you want to do practice all this on your own is to set up a cloud account, Google Cloud, Azure Cloud, or AWS Cloud. Okay, create a Kubernetes cluster and try to put things there. Then you will understand it gradually. How things
Creating
are.
a cluster, it does not take any charge or anything.
It takes some charge, but let's say you can simply pay as you go just to test it out. You can see some servers are free just for testing purpose. You might not be even charged at some places. Okay, if you're hosting big applications, then suppose you just create a simple database of 100 rows, right? That you will not be charged for that if you just want to test it out.
So basically, my concern was you very nicely explain all of these concepts, but
Yeah.
I generally see when it comes to the architecture or making a map, it comes up with the experience, right? So
Yes.
how can someone like who do not have any experience, like a fresher, or let's say who do not have any knowledge regarding it, how to uh, go with that pace? Like, what should be the line of thought
So
when I have
first
to learn? And
first part should be simply building the application, whatever you're doing. Let's say you're building a Gen application, right? First, you
okay,
should focus on that only. This expectation, this type of thing, what I'm explaining, is not expected from freshers. Okay. So if you're coming out of just 1-2 years of experience, people will not expect this level of thing from you in the company. But as you grow, suppose you have worked 5-6 years down the line, right? Then people start expecting this kind of things. So like, does not matter how much you do on your own on your cloud or whatever, the thing that you will experience in a company will always be better, will always be different, right? So don't worry about that. I'll recommend, first of all, so what is a good roadmap for this is that first build the application yourself, then gradually see, okay, can I host my application on my single computer? Let's say you'll take a Docker and you will try to host it. I'll give a proper roadmap, don't worry, right? Then you will see, okay, let me share link with people, and what can I do next, right? Can I put it to some clouds to see the performance, right? I mean, that's how you learn. I'll give you proper roadmap, don't worry about that. But this idea of telling all this was not to scare you, was just to tell you what all things are there. Okay.
okay, understood. Thank you.
Okay, so let's move towards data centers. Do you know what is data centers? Anyone who knows?
Basically, this is where you keep your servers, like generally in
Yeah,
your own premise, basically.
exactly. The servers that you are seeing right now, right? They are all these servers can remember what is the whole concept that we have been reading so far. We want to reduce our dependency on one single thing. Agreed? When we saw one server, we horizontally scaled it. When we saw one database, we created copies of it, right? And similarly, other things we do. Same thing for servers as well, that what we do, you would have seen whenever you run on AWS or any cloud, you will see set your zone, something like this you might be seeing, right? So companies have data centers at different places, uh, of at least 3 to 4 places, right? So all those servers are stored at those locations. So what happens that whenever now whichever server is close to you, or whichever data center is close to you, you will be connecting with that particular location. Suppose you're sitting in Delhi, you'll be connected to a server which is close to you, not something which is in, let's say, US, right? That's how things work. So similarly, whatever we done, a copy of will be created, and one will be stored in one data center, one will be stored in one data center. So that even if one data center fails, you will be routed to the other data center. Okay. And this is how companies basically scale, I would say, their dependence, so that they do not rely on a single data center. Okay, so this is our architecture so far, that whatever we did, we have increased to data centers as well. All clear, guys?
So they have backup for everything, like data
They're back,
centers,
they're
like databases.
backup. Everything is backed up. So something like this is there. Okay. Now coming to the last thing, this is called message queue. What happens that Suppose there's an application where you upload your picture and you want to put some filter in it and you want to download it. Okay, so think like this. This is an application. This is an application. You want to upload your picture and you want to, let's say, apply filters, and then you want to download it. Now think like this. You're not the only person who is using an application. There are multiple people who are using application, right? So how your request is processed. Now there comes a concept of asynchronous. We also call it asynchronous programming. Okay. What happens that, so you will see the concept of producer, publisher, and a consumer. Whenever you send a request, so what is happening? You are sending a request, which is your request one. Similarly, tons of requests will be coming, right? So tell me, if one request, let's think like this. Let's think like this. Let's take a very simple example of a GPT call that we do. Okay. Suppose I've created a GenAI application here, which is connecting to OpenAI, and 5 people are sending request. So let's say person 1, person 2, person 3, person 4, and person 5. Each GPT call, suppose, takes 10 seconds. Now, let's say person 1 came first, person 2 started sometime, person 2 started 1 second late, this started 1 second late, this started 1 second late, this started 1 second late, right? So how will it work? Will it first process, take 10 seconds to process the first person, then 10 seconds for the second person, then 10 seconds for the third person? So will the fifth person get response after 50 seconds, or will he get in the 10 seconds only?
10 seconds only.
10 seconds.
So how does this work? This works through the concept of asynchronous programming. So what happens that when person 1 requests something, let's say this is your OpenAI model, okay? When it will request something, so suppose it takes 10 seconds to answer. Now server will not wait for this to finish and then take up the other load. The moment you have sent a request, parallelly it will start executing the second one as well. Okay. Then the moment it sent the request, it will start the request for third as well. It will start the request for this as well, and it will start the request for this as well. Okay. There might be a delay of 1 second, but what will happen? It will take the request of this. The moment it starts the request for this, it will not wait for it to finish. It will start the process 2. Then once it started the process 2, it will immediately start the process 3, then process 4, then process 5. So all these requests will go in parallelly. They generally go in form of batches, or they go in form of this is called a message queue, right? So all these message queue are created, and that is how multiple requests are handled together. Okay, so how does it work? Producer, which is you create a task. Basically, you will create a message. You will say, okay, I want to do this thing. Now this message will send to a queue-like structure, right? One or more consumer, which is the application, it will pull tasks from the queue and process them. Once processed, the task is marked, done, and removed, right? So you send request, it will take request from you. While it is waiting the result of yours, it will take the other task as well. It will take the other task as well. It will take the other task as well, right? So think like this: you are working in a kitchen, right? You are parallelly boiling water as well. You are parallelly cutting vegetable as well. Meanwhile, water is boiling. You are cutting the vegetables as well, right? You don't do that. Okay, let the water boil first, then I will cut the vegetables. You can do both of the things parallelly, right? This is how this message queue works. Okay, and this is how requests are processed fast That's how multiple people, when they connect to a server together, everyone get the result instantly. It does not wait. Otherwise, it will be a long queue, which will be not be able to resolve, right? So, is it clear, guys? Any doubt?
So message queue is like storing the queries like which is being asked or what?
Message queue is getting the user request, storing them, and answer in that order only. That, let's say P1 came, it will start this one, then it will. So it technically means that it will receive all the requests, process, let's say 10 requests per second, right? And it will answer 10 requests per second. In the next queue, it will answer 10 more. In the next queue, it will answer 10 more. That's how it will work. Any doubt, anyone? After this, there is nothing. This is logging metrics and automation. Logging just means that whatever you do, you basically, while writing Python code, you would have heard logging, right? You want to print statements at every error so that you can debug your errors, right? You want to measure the KPIs and all that. So that is something logging. And one more thing, last topic is database scaling. What you do that, suppose whenever your information is coming, you don't store all the information in the same database. There's a concept of called partitioning and sharding, right? What it does, it splits the large databases into smaller pieces called shards for easier management. So what does it do? Suppose you have a user ID from 0 to 100. Not all user ID will go in the same. So for this single database, multiple shards will be created. Some information will go to this, some will go to this, some will go to this, some will go to this. So data will be basically partitioned. So sharding is a technique to split a large database into smaller, faster, and more manageable parts called a shard. Each shard has the same database structure because we are just splitting a single table, but contains different subset of the data. It helps systems scale horizontally and same concept. We don't want to put all our data in same database. That's why we split it. And this splitting is called partition, or you can also call sharding. Okay. So this is our final design that of our application. The session is done from my end now. Please have a look at it. If you have any question now, you feel free to ask. If you guys learned anything, do let me know that as well. You can put on group whatever you learned, but I just wanted to explain theoretically that how things work in the backend. When you will actually work on them, they are more complex, but just wanted to put some curiosity in your mind that how things are working, right? So yeah, if you have any question, please feel free to ask. And yeah, if you're good, you can drop off from the session. Thanks for joining, and do provide a feedback on the group how if you like the session, right? And I'll try to bring up more sessions like this, right?
Satvik, if you provide any hands-on like in the live class, so it will be very much helpful, like so
Yeah,
that we will understand all the.
yeah, I will provide. I will provide. Don't worry. It's just that in 1 hour I cannot do all that, but I will definitely provide hands-on experience as well.
Yeah, is it possible to have some session where you actually work and people see?
Yeah, I will show you. Maybe I can show you how Kubernetes cluster is set up, right?
Yeah.
Those things I can show you. But read about these little bit more, right? I will definitely come up with practical session as well.
That will be great. Thank you very much for your time, and it was really a very fruitful session. Thank you very
Thank
much.
you. Thank you. Thank you. Thank you, guys. You can drop off. And YouTube channel is Data Sense. Please WhatsApp me. I will send you. Okay. PPT. So I will upload this video on YouTube, and in the description I will add the PPT. You can have it from there, or you can WhatsApp me as well. I will share the PPT.
Which number do we have to WhatsApp?
This 2018936385, right? That's my number. You can WhatsApp me on that. Okay, guys. So if no one has any question, feel free to drop. Enjoy your Sunday, and let's see you in some other day, right? And do let me know the feedback on the group as well, please, if you liked it. And I will upload this video to YouTube in a couple of hours. So thanks again for joining, and I'll try to come up with a practical session as well. Okay, but do read, explore these topics more on your own as well. Okay. Thank you, guys.